In this video, I'm going to demonstrate how to divide polynomials using both long division and synthetic division, which is a shortcut. Um, so to start off with, let's review the vocabulary that we use when we divide. The thing in the front that we divide by is called the divisor. The thing that gets divided is called the dividend. And the answer is called the quotient. And I want to review how we do long division with numbers first, because it's probably been a while. So we take the divisor and we put it in the front of this long division symbol, which almost looks like a square root, but it's not. And then the dividend goes underneath. Now, we first divide the divisor into the first digit of the dividend. 4 goes into 6 one time. I put a 1 up above the 6. And then I multiply the 1 by the 4, and I get 4. And I write that below. Then I subtract. 6 minus 4 is 2. Then I bring down the 7. Now I take that 4, the divisor, and divide it into 27. Or I ask myself, how many times does 4 go into 27? And 4 times 6 is 24, so it goes in 6 times. 6 times 4, then I multiply the 6 by the 4, and we get 24, subtract, we get 3, bring down the 7. Now I see how many times 4 goes into 37, and that's going to go in 9 times. 9 times 4 is 36. I subtract, I get a 1, and without going into decimals, I call that the remainder. So my answer is 169 remainder 1, or I could think of this as 169 and 1/4. So I can take that remainder over the divisor. And that's another way to think of our answer. Okay, so now we're going to do this with polynomials in pretty much the same way. So we write, if we're dividing this longer polynomial by x minus 3, 2x to the third minus x squared plus 3 needs to go under my division symbol. But I need to make sure that I have a space for every power. I've got 2x to the third minus x squared, and there's no x term. So what I need to do is I'm going to erase my 3 and add in a 0x before I put in the plus 3. So whenever you're missing one of the powers as you go down, you need to put in a 0 to hold the place for that term. Now in the front, I'm going to put x minus 3, my divisor. Now to divide, I take just the x in the front with the first term, and I ask myself, how many times does x go into 2x to the third? Or what would I multiply x by to get to x to the third? And that would be 2x squared. And I'm going to write that above my x squared term to keep all my x squared terms vertically aligned. And then I multiply 2x squared by the x and by the minus 3. So 2x squared times x is 2x to the third, and it should match the term above it. Then 2x squared times minus 3 is minus 6x squared. Now our next step is going to be to subtract, just like we did with numbers. Now I have to subtract this whole expression. So I've got to distribute that negative, and so when I distribute the negative to the second term, it's actually going to become a positive. So 2x to the third minus 2x to the third cancels out, and we get negative x squared plus 6x squared, which becomes 5x squared. Now I bring down my next term and I divide again. So I take x and compare it with 5x squared. And the question is, what do I multiply x by to get 5x squared? That would be 5x. It goes on the top. And now I'm going to multiply 5x times x and 5x times 3. 5x times x is 5x squared. 5x times negative 3 is minus 15x. Now I subtract. And my first term is going to cancel. When I distribute my negative, this one becomes a positive 15x. And 0 plus 15x is 15x. Now I bring down my 3 and divide again. X goes into 15x 15 times, or I would multiply x by 15 to get 15x. Then I multiply 15 by x and 15 by minus 3. And we get 15x minus 45. Now I subtract. The 15x's cancel. I distribute that negative. This becomes a positive, and 3 plus 45 is 48. Now I know I'm done when the degree of this is less than the degree of my divisor. And 48 is a constant, so I'm done with my dividing. That's going to be my remainder. So my answer, or the quotient, is 2x squared plus 5x plus 15. And then my remainder, 48, I write as 48 over, plus 48 over x minus 3, whatever you divided by. And that would be my final answer. I'll do one more example of dividing using long division. So first I write x to the third minus 1 in front, and inside my division symbol, x to the fourth plus 4x to the third. Notice I have no x squared term, so I need to say plus 0x squared minus x minus 4. So again, if one of your powers is missing, you need to put a 0 in to hold the place. Now in the divisor, I don't need to do that. X to the third minus 1 is missing the x squared and the x, but it's okay in the divisor. It will work out. Okay, now first I divide, so x to the third goes into x to the fourth. Well, x to the third times what is x to the fourth? And that would just be x. So I'm going to put that way over here above the x. And then I multiply x times x to the third and x times minus 1. X times x to the third is x to the fourth. It goes below x to the fourth. And x times minus 1 is minus 1x. That's going to go below my x term. So I always want to line up my terms by power. And now I'm going to subtract. And since I'm subtracting both of these, this x over here is going to end up becoming positive. So x to the fourth minus x to the fourth cancels out. And then when I subtract, there's nothing here, so it's like a 0. I still need to subtract those. 4x to the third minus nothing is 4x to the third. 0x squared minus 0 is 0x squared. And then we have negative x plus x, which actually cancels out, so we get 0x, and then I bring down minus 4. Now I divide again, so I compare x to the third with 4x to the third, and I ask myself, what would I multiply x to the third by to get 4x to the third? And that would just be a 4. So I put a 4 up here, and then I'm going to multiply that 4 by x to the third and minus 1. 4 times x to the third is 4x to the third. 4 times minus 1 is minus 4. And again, I line up my terms so each column has the same power. These would be zeros in here, and I subtract. So 4x to the third cancels. That's nothing, and actually this cancels as well. We end up with 0, which means that there's no remainder, or that x to the third minus 1 divided into that expression evenly without a remainder. So our final answer is just x plus 4. Now we're going to divide polynomials using synthetic division. Now, synthetic division only works when your divisor is in the form x minus c, or when you're dividing by a linear factor. So we wouldn't have been able to use it for the last example. Okay, so what we do is we take the divisor and we find the c value. The c value is like the 0 if x minus 3 is the factor. That's going to be positive 3. So it's basically the opposite of the number that shows up right here. And we take that number and we put it in a little corner. Next, you're going to list only the coefficients of the numbers in the dividend. So 2x to the third, I'm just going to put the 2. Then we have minus x squared, so I'm just going to put negative 1. There's no x term, and I have to put a 0. Very important. If I don't put a 0 for my x term, it's not going to work. And then I put a 3. Then I make a vertical line between my last two numbers, and I leave space for another row of numbers and make a horizontal line. Then what you're going to do is take the very first number, not counting the 3, the first coefficient, and bring it below the line. Then you're going to take the 3, the number in the box, and multiply it by the number below the line. 3 times 2 is 6. Then we add these two numbers. Negative 1 plus 6 is 5. And then we multiply the 3 by the 5. We get 15. We add 0 plus 15. You get 15. Multiply 3 times 15. You get 45. Add 3 plus 45. You get 48. And the very last number is going to be the remainder. And then as you move to the left, your next term is going to be the constant, then the x term, then the x squared, and so on. So our answer, these are going to be the coefficients of our quotient. So the quotient is going to be 2x squared, because of this 2, plus 5x plus 15, and then remainder 48, so we say plus 48 over x minus 3. Now this is the same problem we did at the beginning of this video, and notice we got the same answer, and maybe a quicker, easier way. One more example using synthetic division. This time, if x minus c is x plus 4, our c is going to be negative 4. So it's like if this is the factor we're dividing by, the corresponding 0 is -4, and that's the number that goes in the little box. Then I list the coefficients of my dividend: 3x squared, 7x, minus 20. And this time I wasn't missing any values. I didn't have to make any spaces for, I didn't have to put in any zeros. Then I make a vertical line between my last two numbers, a horizontal line leaving a space for another row of numbers. I drop the 3, the first number after the box, down below the line. I multiply the number in the box by the number below the line. So -4 times 3 is -12. Then I add 7 plus -12. I get -5. I multiply -4 times -5. I get 20. I add -20 plus 20. I get 0. That's my remainder, my constant, my x, and so on. So my answer, the quotient, is going to be 3x minus 5, and this time no remainder, which tells us that x plus 4 is a factor of that polynomial.